Everybody, this is the Algebra 2 lesson for 5th hour on graphs of polynomial functions. What you'll have is you guys should have this sheet in front of you from Mr. Bestel, all right? What I'm going to do is I'm going to run through a couple of questions with you, and we're going to make sure we can write some equations. So the first thing I wanted to look at with you guys is a little review in like number 1. So write the equation for the polynomial function given the following information. So for A, it looks like I have zeros. Remember, those are my x-intercepts of 3, -2, and 5. Now, the curve is going to pass through all those x-intercepts. So let's see here. We're going to graph. What we're going to do is we're going to make this equation. So it looks like this would come from like an x minus 3, right? And this guy would come from a factor of x plus 2, and that would come from an x minus 5, and that equals y. What we're going to do next is we're just going to make sure that that actually happens. So if I have an x minus 3 times an x plus 2 times an x minus 5, it should pass through all those points. I'll do a zoom 6. At 3, we're going to go here. So it passes through at 3 right here, sorry, 5 there, and -2. Feeling good about that? That's my equation. All right, so that's A. Let's look at B. The zeros of the polynomial function are 4 and -2. All right, at -2, it touches and turns. That's important. All right, so what did this factor come from? The 4 came from a factor of x minus 4, and the -2 came from a factor of x plus 2. That equals y. Now, if it's going to touch and turn, it's almost like looking at a parabola. Like if we had the parabola of x minus 3 squared, wouldn't that be, move it to the right 3 like this? That would be 3. So it touches and turns when this is even. Therefore, if it's touching and turning at -2, that should be even, and we're going to square it. So we're going to have x minus 4, and then an x plus 2, and I'm going to square this. We'll see what happens. All right, so it should pass through at 4, touch and turn at -2, and it does. So I'm feeling good about that. Okay, then I had a next review question. Describe the end behavior. All right, so my end behavior is going to come from the leading term. That is my leading term. So my degree is odd, and therefore I know it's going to go in different directions. Now, lots of kids forget, which directions is it? Is it rising or falling, to the right or to the left? Well, you can always go through those questions. Just focusing on this, if I use a positive x, any positive x raised to the 5th power is going to be positive, multiplied by -3, it's going to drop, it's going to be negative. Any negative x raised to the 5th power, it's going to be negative. A negative times -3 is going to be positive. Therefore, kind of like what you did in your homework, as x goes to negative infinity, we'll do that one, your y is going to go to, well, it's going up, it's going to positive infinity. And as x goes to positive infinity, your y is going to go to, as my x's go to the right, my y's are going to negative infinity. So there you go. That's a little review on that. All right, number 3. So on your worksheet, I'm going to have you guys add a point to that in just a bit. Right, the polynomial equation for each of the following functions is having x-intercepts enough. All right, so for A, when I'm looking at that graph, you guys, I'm seeing that it has to pass through x-intercepts of -3, 0, and 2. And it passes through. I'm also seeing that it has to contain, this one's easier to see. You guys, it has to contain the point -2, 8. So what I'm going to do is create my equation like I did up here, and then I'm going to make sure that it actually works using my calculator. So x minus 3 came from an x plus 3. 0 came from x minus 0, and 2 comes from a factor of x minus 2, right? Now, x minus 0 is just x, so the way you're going to see that is x times an x plus 3 times an x minus 2. So it looks like that's a good function, and I want to see, that is the zeros, does it pass through -2, 8? All right, so I'm going to have an x, and then an x plus 3, and then an x minus 2, and then I'm going to look at my graph. So there's one at -3, 0, and 2. Feeling good about it. Doesn't that look like pretty much like what I have there? Yes. All right, B. Again, if you look at that, it has x-intercepts at -3, 0, and 2. Now this time it passes through. It's hard to see it, but it passes through at 1, 4, and -1, -6. Trust me on that one. All right? Now here's the deal. Aren't these x-intercepts the same? So my factors that they come from are going to be the same, but the graphs obviously don't look the same, right? For one thing, this one rises to the right and falls to the left. This one rises to the left and falls to the right. All right. So these zeros come from x plus 3. This guy was the x, and that was x minus 2. Now, here's the deal, you guys. Do you see how these things pass through nicely? This guy passes through as well at 0, but it kind of flattens out. That means there's something going on with its exponent. Well, it's definitely not even, because even exponents make it bounce. So let's make this a 3. Let's put a 3 by this guy, and let's see what happens. Oh, and the other thing, almost forgot. If there's a positive out here, wouldn't it rise to the right and fall to the left? Okay, let's make this negative out here. So let's go with negative x cubed. And then I'm going to have an x plus 3 and an x minus 2. And I'm going to check my graph. I'm going to do that first. Let's just look at the graph. Ooh, yep, I have this really funky thing going there. And if I want to, I can actually change my window to look like the one in the picture and make the x's go from -4 to 4. And then the y's, what do they go from like -40 to 15? Little tennis numbers there. All right. And, whoo, look at that. If I look at that, I'll fold mine over. Whew, doesn't that look good? Does it contain 1, 4, and -1, -6? 1, 4, -1, -6? Yep, looks like just having the x-intercepts and knowing what's happening there, so far it looks like that's all I need to know. Okay, third one, this guy right here passes through at -2 and 1. Let's see, sorry. So this guy would come from a factor of x plus 2. This one would come from an x minus 1. Now, does anything touch and turn? Yeah, it touches and turns at -2. Therefore, that means the factor it comes from has to be even. Factor is going to have an even, we call that multiplicity. All right, this has to contain, looking at the graph, this one was pretty easy, 0, 8. All right, so here we go. We're going to have x plus 2 squared, and then x minus 1. And then I'm going to make sure, let's look at the graph. Does it look like that? I'm going to do a zoom 6, sorry about that. Let's do a zoom 6, look at that. Ooh. Oh, look at this for C. I forgot to add something. Sorry, I'm going to fold this over again so that I can see my graph just a little better. All right, so this is C right here, you guys. Isn't it rising to the right and falling to the left? I need it to go the other way. So I'm going to make a negative right here. Ooh, there you go. So that looks pretty good. Now the question is, does it contain 0, 8? No, it doesn't. That's 0, 4. So, is it enough to have the x-intercepts? No. You need another point. Not just the x-intercepts. All right, you just need a point. So if you have the x-intercepts and a point, you guys, you are good to go. Okay, that brings me to number 4. There's a couple of them. I have A, B, and C. This is where we're ending our little journey today. Write the equation for the polynomial given the following information. The x-intercepts are, I got x-intercepts that are very similar to what I have here. X-intercepts of -2, 1, and then 6, and passes through all those points, and it contains 0, 30, -36. All right. So here's the deal, you guys. If I have this, wouldn't this come from a factor of x plus 2? 1 would come from a factor of x minus 1. And 6 would come from a factor of x minus 6. Now, that is not containing, I bet you it's not containing what I need, 0, -36. So I have x plus 2, x minus 1, and x minus 6. Does it contain 0, -36? Absolutely not. So now I need it to contain 0, -36. Do you guys remember that when we did polynomials, or we did quadratics, we had like an a factor we had to find? That was a stretch factor. Guess what, guys? There is a stretch factor here, and it goes right there. If it's negative, wouldn't it flip it? That's what I did over here in this guy, right? I flipped it, and that worked. I'm not sure if flipping is going to work on this one. All right, so we'll see what happens. Let's see the graph on this one. So it does rise to the right and falls to the left like it's supposed to if it's positive, but I need a stretch factor. So what we're going to do is we're going to use 0, negative 36 to find A. All right, here we go. What's my y? My y is negative 36. That equals, I don't know A. I'm going to put 0 in for x plus 2 times my x is 0 minus 1 times my x is 0 minus 6. All right, negative 36 equals, this is going to look similar to what you've done before. 0 plus 2 is 2. 0 minus 1 is negative 1. And 0 minus 6 is negative 6. Negative 36 equals, all right. 2 times a negative 1 is negative 2 times negative 6 is 12. Divide by 12. A equals negative 3. So my equation should be negative 3 because that's my A. It's going to look exactly like that. Times x plus 2 times x minus 1 times x minus 6. And let's see what happens with that. When negative 3 times x plus 2, x minus 1, and x minus 6. All right, let's just make sure it contains, what was the point I needed? 0, negative 36. There it is, 0, negative 36. I'm feeling good about it. And my x-intercepts, what did I say they had to be? Negative 2. There it is. It had contained 0, negative 36. I needed 1, and then I also needed 6. There we go. Fantastic. So that's what we need to do, you guys. We need to come up with our factors, and we're finding a stretch factor. Welcome to what we're doing today. All right? All right, so that was A. Let's go to B. So for B, you guys, I'll fold this again. Actually, I'll put this right here. Sorry for the folding. Write the equation for the function for the polynomial. It should be for the polynomial below. I will make sure that you guys do that. So it should be below. All right, so it looks like I have x-intercepts of what? 0, negative 1, negative 3, so I have negative 3, negative 1, and it looks like I have 2, right? All right, here we go. We have x plus 3 comes from that guy, x plus 1 comes from that guy, and x minus 2. We need an A factor, and we need it to be y, so that's what I'm going to do. All right, so what I need to do, you guys, is I need to have a point in which I can use to figure out what the equation is going to be for that little curve, right? All right, so it's kind of hard to see what the point is going to be for that little curve, so I am going to look it up. Let's see here. For B, sorry about that. I need to check to make sure that I have this guy. And we are looking for the point 116. Sorry about that. This point right here is the point 116. All right, and I will have that on I will switch those things on your worksheet. All right, so it contains the point 116. All right, we have all the things we need. The other thing is though, hey, look at what's happening here. It's bouncing. Doesn't that have to be squared? Yep, here we go. All right, my y is 16. That equals my A, I don't know that, times my x, which is 1 plus 3, times my x, which is 1 plus 1, times my x, which is 1 minus 2, and we're going to square that. 16 equals A. 1 plus 3 is 4. 1 plus 1 is 2. 1 minus 2 is negative 1, and I'm going to square that. 16 equals 4 times, okay, negative 1 squared I should start with because it's exponent. So this is 1. 1 times 2 is 2. 2 times 4 is 8. This is going to be 8a. Divide by 8. Wouldn't a have to be 2? So looking at this, it's going to be y equals 2 times x plus 3 times x plus 1 times x minus 2 squared. Let's make sure that that contains all those points. All right, we're going to have 2 times x plus 3 times x plus 1 times x minus 2 squared. All right, here we go. Do we have points at negative 3, 0? Yep. Negative 1, 0? Yep. 116? Yep. 2, 0? Yes, that works. This is my equation. I'm good with that. All right, C. All right, for C, write the equation for the polynomial. Write the equation for a polynomial equation for a function with a graph that bounces off the x-axis at. Okay, it's going to bounce off at negative 1, 0. So I'm going to have a 0 there. Crosses at 4, 0, and passes through -2, -18. So my x-intercepts are going to be at -1 and 4. This one, it bounces. All right, so -1 would come from a factor of x plus 1. 4 would come from a factor of x minus 4. If it bounces, it needs an even exponent. I'm going to put a 0 or 2 there. The other thing I told you is that it contains, what, -2, -18. All right, I need an a value, and that's going to be y. All right, so with this point, what's my y? -18. That's going to equal a times my x, which is -2, plus 1. We're going to square that, times my x, which is -2 minus 4. All right, -18 equals a. This is going to be -1 squared times -6. -18 equals a times -1 squared is 1 times a -6. -18 equals 1 times -6 is -6a. Divide by -6, a is 3. So we're going to have y equals 3 times x plus 1 squared times x minus 4. Let's see if that works. 3 times x minus 1 squared. And that's times x minus 4. All right. Do we have one at -1? No, I must have put something in wrong. Oh, it should be x plus 1. My bad. See? Got to put those in right. Okay, do I have one at -1? Yes. Do I have one at 4? Yes. Do I have a point at -218? Yes, that works. This is my equation. All right. So that is what you're looking at doing today, you guys. You're going to have these factors. You're going to find your a value, and that is what you're doing. I apologize for that little blurb in part B, but I will change that number and make sure you guys have that point on your worksheet. Good luck, and I will see you soon.